Here is a question on Doppler effect. The speed limit for vehicles on a road is 100 किलोमीटर पर आवर. एक रोड पर स्पीड लिमिट है, लिमिटिंग स्पीड है 100 किलोमीटर per hour. Okay. A policeman detects a drop of 20% in the pitch of the horn of a car as it passes him. Pitch मतलब frequency. एक policeman खड़ा है and a car is passing him. So when the car passes him, he notices a drop of 20% in the frequency of the sound of the horn. मतलब car when it is approaching, its frequency will increase. When it moves away, its frequency will decrease, and he notices a drop of 20% in this frequency. मतलब 20% से frequency कम हुई, मतलब कितनी हो गई 80%. The frequency dropped by 20% means it became 80%. Means suppose here is the policeman standing, the car approaches him. Suppose NA is the frequency of approach. The car moves away from him. Suppose NR is the frequency of receding, means going away. So there is a drop of 20%, means NR, the receding frequency, is 80% of NA. The frequency drops by 20%, means remains 80%. So NR is 80% of NA. Fine. Is the policeman justified in punishing the car driver for crossing the speed limit? मतलब उस कार ने स्पीड लिमिट क्रॉस किया है क्या, उसको वो फाइन कर सकता है क्या कि स्पीड लिमिट 100 किलोमीटर की क्रॉस हो गई. Means you have to find the speed of the car, means you have to find the velocity of the source. You have to find velocity of the source. And the policeman is stationary, means velocity of the observer is 0. And velocity of sound means V is given, that is 340 meter per second. This is your given data. Now you have to find Vs and rest of the things are given. हमारा फॉर्मूला यूज करेंगे हम जो अभी हमने देखा, NA is equal to V plus minus VO upon V minus plus Vs into N. N is the original frequency. Now in the first case, when the car is approaching, NA is equal to V. अब फर्स्ट साइन लेंगे कि सेकंड साइन लेंगे? द कार इज कमिंग नियर, मींस यू यूज फर्स्ट साइन, मतलब ऊपर प्लस और नीचे माइनस. V प्लस VO, ऑब्जर्वर की वेलोसिटी 0, अपॉन V माइनस VS means velocity of the car. Source is the car, and this velocity you have to find out, into N. We don't know what was the original frequency. So NA, the frequency of approach, is V upon V minus VC into N. This is the frequency of approach. Frequency while receding will be again the same formula, V plus minus VO upon V minus plus VS into N. But now you will have to use the second sign. Why second sign? Because the car is receding, going away, तो ऊपर माइनस और नीचे प्लस. So frequency of recede will be V minus VO is 0 upon V plus velocity of the car into N. This is the frequency of recede. And NR upon NA, if you take, दोनों का अगर रेशो लो आप, that will be equal to V upon V plus VC into N divided by this, means multiplied by V minus VC upon V into N. so that this N gets cancelled. So NR upon NA is V minus VC upon V plus VC. NR is 80% of NA. So 80% of NA और नीचे NA is equal to V minus VC, 340 minus VC upon V plus VC, 340 plus VC. This NA gets cancelled, 0, 0 cancel, 2 4s are, 2 5s are. Now what will you do? You will cross multiply. So cross multiplying 5 into 0, 0, 5 4s are 20, carry 2, 5 3s are 15 plus 2, 17 minus 5 VC is equal to 4 से multiply करो 0, 4 4s are 16, carried 1, 4 3s are 12 plus 1, 13 plus 4 VC. ये minus 5 VC उधर ले जाओ, 4 VC plus 5 VC, that is 9 VC is equal to 1700 minus 1360. That is 340. So VC is equal to 340 by 9 meter per second. We have taken all the quantities in meter per second, but the speed limit is given in kilometer per hour. So you'll have to convert this into kilometer per hour. So this will be 340 upon 9 into 18 by 5. You know the conversion, meter per second into kilometer per hour. 9 ones are, 9 twos are, 5 6 are 30, carried 4, 5 8s are 40, 2 8s are 16, carried 1, 2 6 are 12 plus 1, 13. 136 kilometer per hour is the speed of the car. Means has crossed the speed limit. Speed limit is 100 and he is moving with 136 kilometer per hour, means he has crossed the speed limit. So the policeman is justified in punishing the driver. A stationary source produces a note of frequency 350 hertz, means the original frequency is 350 hertz. An observer in a car moving towards the source, this frequency is released from a stationary source, means velocity of the source is equal to 0. The source is the source is stationary, so Vs is equal to 0. An observer is in the car which is moving. Okay, moving towards the source. Car is moving towards the source. Observer moving towards the source. Okay, and he hears the frequency as 370 hertz, means the apparent frequency heard by the observer is 370 hertz. Okay, find the speed of the car, means you have to find the velocity of the observer, speed of the car. आगे क्या बोल रहा है? What will be the frequency of sound as measured by the observer in the car if the car moves away from the source? अब ये first condition यहाँ पर खत्म हुई. Now what he says, what frequency will be heard, means NA will be equal to what? When observer moving away from the source. That is your second question. And velocity of sound is given, that is 340 meter per second. What you are going to do? Your usual formula, NA is equal to V plus minus VO upon V minus plus VS into N. Put the values in this formula. First you will decide the signs. Moving towards the source means first sign ऊपर प्लस नीचे माइनस. NA is 370. The apparent frequency heard by the observer is equal to V 340 plus observer velocity you have to find out upon 340 minus Vs is 0 and into N, the original frequency is 350 hertz. So 370 is equal to 340 plus VO upon 340 into 350. This 350 you can take to this side. Now you can calculate with cross multiplication, you will get the velocity of the observer, right? And second question, you'll use the same formula. NA is equal to V plus minus VO upon V minus plus Vs into N. But now, as the observer is moving away, you'll use the second sign, मतलब ऊपर plus और नीचे, sorry, ऊपर minus और नीचे plus. NA, you have to find out. V is given. VO, you found out from here. यहाँ से आपने VO find किया. Vs is 0. This is also given. And N is also given. You'll get the apparent frequency. And your answers should be speed of the car, the first answer, 19.43 meter per second. And second answer is 329.41 hertz.